Hello guys, in this video I will explain to you how to create a circle a graph like this. In today's flip class in general, we're going to talk about the different distributions with Tableau and multiple axes. The first thing I want to talk about is a circle chart as part of the distribution. Then we're going to talk about box and whisker, and then histograms, the very popular histograms. So often simply understanding totals, sums, and even the breakdown of part to whole only gives a piece of overall picture. Most of the time, you will want to understand where individual items fall within a certain distribution of all similar items. So you might find yourself asking questions similar to this. How much does each customer spend at our stores, and how does that compare to all other customers? How long do most of our patients stay in the hospital? Which patients fall outside the normal range? Also, questions like what's the average life expectancy of components in a certain machine, and which components fall above or below that average? So understanding which ones falls below or above an average could be answered also by looking at distributions. How far above or below passing were students' test scores? Very basic examples, right? So these questions all have similarities. In each case, we are speaking about a certain kind of aggregation or understanding all these individuals, patients, components, students. How do they relate to one another? In each case, you most likely have a relatively high number of individuals. In data terms, you have a dimension like a customer, patient, component, and student representing a relatively large population of individuals in some measure, like the amount of money spent or budget spent, the length of stay, the life expectancy, the test score, and you'd like to compare using one or more of the following visualizations that we're going to learn in class will help you understand the relationship between these items in within this big group of data. We're going to start with the circle chart. A circle chart should look something like this. These circle charts are very good to visualize any distribution. And I would like you to consider the following view, which shows how each doctor compares to other doctors. So each circle represents a doctor and how they compare to each other when it comes to the time to service. So in terms of the average number of minutes it takes to start a treatment with a patient. Under the assumption that nowadays hospitals are just businesses and the shorter time the better, unfortunately, you can easily see that certain doctors do better or worse on average than others in terms of the time it takes them to start treating a patient. So over here, this line, this reference line is actually the average. So it is also interesting to note that certain types of departments take more or less time on average. So this department on average almost the same as this department, and they are the shortest. This department takes, the general department takes a higher average in general, or has a higher average. This makes sense as each type of department has different constraints and operating procedures. There are also certain departments where time is more critical. For example, we have the intensive care. So they are more critical than others. Being able to evaluate doctors within their type of department makes these comparisons far more meaningful, isn't it? So we can see that you are falling way below the average or above the average or just fine on the average. How do we create a circle chart? In our example, we'd like to create the circle chart by having three very important fields. We have the minutes, the average minutes to service, and then we have also the department and the doctors in each department. So the axes here, the vertical axis will be the department, I believe. So let's add on the rows, let's add the departments on the rows, right? Here's different departments. Or shall we just work with department type? Let's just put department type for now, and then we have the minutes to service, and this is supposed to be in average because this is the question, or this is what we're doing right now, is the average sorry, the aggregation here is the average minutes to service. Let's give it some color based on a different department. But actually we're looking for a circle, not a bar, so we need to change the automatic bar marks to a circle. All right, so now as you can see, we don't have any details. We just have each department have a circle, which is the average minutes to service here, as you can see. But we would like to add the doctors in each department as a detail. So we're going to add the doctors here into the detail, so that now we have different doctors. As you can see here, I can't really see which is which. There are some circles on top of the others. They're overlapping. Probably I could help if I add a border. So I'm going to add a border here. Now I can at least see some circles. Definitely we can change the transparency of the color, the transparency or opacity, so I can see better the circles, so I can see to how many circles here, maybe 1, 2, it's very difficult to see. Over here maybe there are 2 circles, 3, I'm not sure. So it's very difficult to see the circles. But in any case, I would like to add the average reference line. So we would like to see the average of the department. So if you notice, before we added the doctors here, that was the average here is 46, for example, the general. Then we added the doctors, and once we added the doctors to the detail, things had changed. So 40 something was the average, right? 45, did I say 45 previously? Yeah, something around 46, 45. So now when we added the doctors, here is 45. So it's halfway through, seems to be, like midway. Not necessarily the median is midway, but in any case, that would be the average. All right, so how do we add a line or a reference line that will mark the average? So I'm going to ask you now to switch to the analytics tab over here, and just to drag and drop the average with 95% confidence interval. CI is the confidence interval. See, we would like the average, but we would like the average per table, a pane, or cell. Just put it over cell for now. So here we go. Now we have the average, as you can see. If you want to add the average as a label, let's check. It will add the average of each doctor. What I wanted is an average for this line. So I'm going to edit. Here is the reference line, and it's per cell, and it's an average, and there is no label. So I'm going to just add a label, which is the value. Is it the value or computation? Oh man, I kind of forgot. Asoka is the computation. Oh no. The value then. So it's the value. Wait a minute. Let me just go back a little before we added the reference point. Let me just get rid of the reference point for now. Remove. Okay, so let's add the reference point again. I can add an average with 95% interval. What happens if I add the reference line and then I add the line as an average? Then I won't have the intervals here. Did you guys see the difference, guys? I hope that you were able to see. Look at the difference here. Average with 95% interval, I will have a shaded area, so that I would know that this is significant. This is the results are significant, means it's in within 95% significance. For distribution, this is very important. These guys may be outliers, so, and these guys are outliers. So what does that say? What does that mean? This means that for this department, even though this person, this doctor, their average 2 minutes to service is 25, the starting minutes to service is 25, seems like they are within the 95% confidence interval. So they are not outliers within this group. The same here, we don't have any outliers. But over here, the 95% confidence interval, we can see that these 3-4 incidents here are actually outside the confidence interval, and the same applies over here. We have some readings outside that 95% confidence interval. You see, this is 95% confidence interval. All right, I don't want this confidence line with the confidence interval. I don't want that. This is so I'm going to just remove it, and I'm just going to add the reference line by dragging and adding it to the cell, and then making sure it's on average, and I'm going to add a value. So I'm going to just have a value here. And if you want to add a certain formatting, for example, if you want it purple and thicker, you can do that, and so on. If you want to have a certain fill here, for example, for anything above the average, you can do that, but I don't want any of that, so I'm just gonna go ahead and that's it. Now take a look at this circle diagram, this distribution. Even though I tampered with the transparency of the coloring, I still see that it's very difficult to make out how many or find out how many circles are within this group of circles. So I'm not sure if there are 2 doctors here and there are circles overlapping. It's very difficult for me to really visualize it very carefully, especially over here, guys. So there's a way to get rid of this by adding a vertical axis here. For each row, for each category, we add a vertical axis, and then these guys will be spread up and down based on that vertical axis, an axis that ranges from 1 to whatever. So for this purpose, I'm gonna create here a calculated field. Here, just create calculated field, and then I already have it created here. So once you create a calculated field, call it jitter, or call it, why would you call it a jitter? Because this is, let me show you here in the slides, I have an explanation of it. Jittering is actually necessary when you are using views like circle plots or other similar visualization types. You'll often see that the marks overlap, which can lead to obscuring part of the true story. Now, do you think you know for certain, just by looking, there are only, for example, how many doctors here in the intensive care? Can you really say for sure that in the intensive care you have 4 doctors? I'm not sure really. Maybe there are 2 doctors here. In this case, there is a technique called jittering, and jittering is a common technique in data visualization that involves adding a bit of an intentional noise to a visualization to avoid overlap without harming the integrity of the data that is communicated. So how do we do that? There is a technique using index or random functions that can be found by searching jittering on Tableau, but you don't have to search jittering on Tableau. Basically, what you're trying to do is to add here an index. So please right click and create a calculated field, or go over here and create a calculated field and call that field jitter or jittering, and then add an index function. Let's see what the index function do so that you understand. The index function returns the index of the current row in the partition. Example, for the first row in the partition, the index will be 1, then 2, then 3, then 4. So basically we will expect now finding or adding an axis here with 1, 2, 3, 4, and so on. So let me just grab this index and adding it. Oh, I can't see anything now. Oh, what happened? I remember this problem has happened once. Actually, it's not. It's okay. So let's continue. I think all is being well here. We had added 0, 1, 2. Yeah, by adding this jitter. We can also get rid of this axis and keep it as is. And here we go. We have 1, 2, 3, 4. We have 1, 2, 3, 4 here, and you can easily see that we have 1, 2, 3. Do you see the 3 here? They were originally looking something like that. They were overlapping with each other, but over here we were able to separate them. Do you see 1, 2, 3? Yeah, so that they can easily be separated. Don't add the jitter over here. It will just do nothing. Yeah, so add the jitter over to the department, and you can show it or you can just not show it. This is you showing the axes here. This is the default, but you can just hide it by either here or either right click over there and hide it. Alright, so this is how the visualization would look like, and now you can easily make out that this is R3 and they are a bit more separated, so you can easily see the distribution. And even here around the average, you can easily see that most of the population is actually around the average. Back here we couldn't really make out that this is the average. They all looked identically intensifying around this whole area, very wider range of area. But over here we can easily see that there's a concentration around this average and a bit of a dissemination farther away from the average reference line. So this is how we create a circle chart for a distribution using the jittering technique for advanced visualization. Okay, so the idea is to add a reference line. You can add an average. You can add an average line in the summaries, or in fact we added here. Oh, we added the reference line in the average line in the summaries, but I also added a reference line. Okay, so guys, in the let me show you. There isn't a big difference. Let me remove this. So previously I added this reference line and I made it an average, but we actually have an average line already made for us. So it's the same, yeah? You just need to add, for example, the value here, and it's identical. Oh wow. In fact, it's because I added the average line after the jitter. So it is showing now, it's all right. Now I can add the jitter here and it should be fine. Oh, it's still added it. So this is there's a reason. It's quite interesting. I'm glad that I didn't forget to show you the difference here. That you can see here the average line here. It's showing the average here and the average there. Even if we hide this, it will still show. You see? So the average line, this is why I kind of like to avoid it. When I added it, did I added it on a cell? Let me just make sure that there is already an average here. So I'm gonna remove this as well. So now all is good. And let's add the average line again to cell, not to the pane. I probably added it to the pane by mistake. I'm sorry. So you now so that, oh, actually it's to the cell. Okay. So average line, if I added, okay. So this is why I like to add the reference line. But even here now the reference line is added to both, because we already have the jitter, but I can easily remove it if I don't like it. And I just can keep the vertical one. So it's good to see how you can edit and manipulate the visualization with unexpected, spontaneously with unexpected results. All right, very good. So in this exercise, we learned how to use the analytics tab. We explored a little bit about on the analytics tab. One last note that I would like to add about the reference line. You can add the reference line also by going down and adding here, add the reference line. And you can see it's the same interface. Today we just focused on a line as an average. You can have a minimum, you have a maximum, you can add a minimum, maximum, an average, a median line. So, and so on. You can add the line only, or you can add it with confidence intervals. We already saw and explored in the analytics tab here how you can actually add it with a confidence interval. So we're going to talk a little bit more about different tabs here. This is with bands. So over here a certain band with computation. If you want the band to be minimum and maximum, for example, or if you want it to be a certain interval, confidence interval, and so on. And over here is the 60-80% of an average. So this is per pane usually, and this is per pane. Here per cell we should add it actually. In our case now we should add per cell. We're going to talk a little bit more about, you can see here you can create a box plot from this option, but let me just talk about the box plot in the next video. All right, so this is it for today. Would like you to create this visualization before jittering. So before adding the index, add the average here before adding the index, and then would like you to also recreate it again with the index, as you can see here. Let me just check. Why don't I have similar results? Honestly, from just the time I've done it before the video, it's just nothing really. Here's the average minutes to service. Here's the department type, and here's the jitter. And this is department type, and here's doctor, and here's circle. Let me see what did I do different? It should be the same, right? So here's department type, and here is the minutes. Is it minutes to service? Did I use a different? It's average minutes to service. All right, so here's minutes to service. I'm sorry, I'm recreating it again because as you can see, guys, there is a slight difference. I just done this before coming to class, like before recording the class, and you can see that since we have an axis here, let me show you the axis. Since we have an axis, it's from 0 to 15. Yeah, and it's department type, that's correct. And as you can see, these guys have been spreading out vertically. Yeah, And I think it's exactly the same as I depicted it here as well. It's spreading vertically. So it should look like this. What am I missing? So this ne over here, let's put it as a circle. And now let's give a color for department type. And we add the doctors to the detail. Is it the doctors or some doctor name or something? No, it's the same. So here's the doctor, and we're adding the doctor to the detail, and of course I've done all the bordering necessary for that. And then we have the jitter as an index, and I added it there. This is continuous. Yes, it is. I need to figure out why also here it's 0 to 15. It's actually counting the doctors. But over here it just sees 1, 0, 1, and 2. It's quite interesting, isn't it? That here it's counting the number of doctors. 1, 2, 3, 4. Let's do it here. 1, 2, 3, 4. But it's up to 15 because we have 15 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's one missing, or maybe I haven't counted it. There's a 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. No, they are all can be seen nicely, and there are 15 of them. Oh man, I really, guys, I don't know. I just created it before recording, as you can see. What happened? I can't get it to. Definitely, it's not here. This is quite interesting. It's the same exact visualization, but maybe I missed out on a point. I feel really embarrassed now. I'm sorry that I'm wasting your time. So I really done everything. This is quite interesting. So here it is. In any case, guys, my second one, the let me add the line. It's added. Did we add it? No. Let me add here the average line on a cell. Okay. And then for the jittering, I don't know why. Maybe cell? No, maybe here across, down then across, no. Across this then down, no. I want it to be just across. Can we do that? Now it's good. Good, good, good. I was about to be very upset with myself and embarrassed since I'm recording. So guys, it has to do with the table calculations. So you just need to make sure that you are doing the computing the axes or the computations happening per doctor, because here we're counting the number of doctors. In fact, for a little while I was approaching it the wrong way, table down and across. No, it's way much easier than this. I think it was maybe even set on department or something, but in any case here we have it as a doctor and it works just fine. And this is how it's supposed to be looking like. So we're adding this vertical axes so that we can see the points spread out. You see the spread out per point, so we can see the spread of the points. All right, so this is it for now. Hopefully this troubleshooting will also help some of us. Maybe it is a good practice if we can hide the axes, and once we hide the axes we'll be able to see less noise. So over here with the yellow, now we can see clearly. The red is actually interesting. Were they 5 in the red? We have a different data here. See, no, the red were these purple ones. Okay, so now we can see everything clearly. All right, this is it for now, guys. I hope this was a very helpful video for you. I will see you in the next video, and in the next video we're going to talk about different visualization, which is the box and whisker plots, which are very important plots for statistics and for like biology and sciences. Thank you so much. I'll see you in the next video.